Suvesh rides a motorcycle northeast at a constant speed along a straight horizontal road. The graph alongside represents the displacement of the motorcycle over a period of 1 minute. What distance has Suvesh travelled after 40 seconds? So if we take a look over here, after 40 seconds, displacement is really just another word for distance, especially if you're on a straight horizontal road. So you're going to have exactly the same. So it's simply a reading off the graph. So up at 40, going across, and we find that we are as close as anything to 275 meters. Chris throws a ball vertically upwards from the top of a cliff at 7 meters per second. The cliff is 25 meters high. Which acceleration versus time sketch graph represents the motion from the time the ball leaves Chris's hand until it lands back on the ground below? Take the upwards direction as positive. Now we know that gravitational acceleration is always 9,8 meters per second squared downwards. It really doesn't matter where that ball is in the air, doesn't matter anything at all except for the fact that it remains completely constant as long as I'm relatively close to the earth. And therefore, I am looking for a constant acceleration over a period of time. Here, it changes direction. The acceleration does not change direction. The acceleration remains at all times downwards. The acceleration does not change magnitude. It doesn't increase and it doesn't decrease. All that you have is one constant acceleration value at negative 9,8 meters per second squared. It's negative because it said upwards is positive, so therefore downwards must be negative. So A is your correct answer. Montana throws a ball up in the air. At the top of its projectile, the ball stops momentarily before returning to the ground. Which of the following free body diagrams correctly shows the forces acting on the ball at the top of its projectile? The only force that acts on any object in free fall is a gravitational acceleration downwards, unless that object is working against air resistance. But when it is stationary, it cannot work against air resistance because it is not moving, and therefore there will be no air resistance. The throw force that is mentioned here happens at the split second that that ball leaves the hand. It is given an upward thrust. But while it is in free fall, and the question is at the top of its projectile, remember, at the top of a projectile, the ball is standing stationary. So the only force acting on it is the gravitational force downwards. D is the correct answer. Bhavani runs a race along a straight horizontal track. Below is a graph representing her displacement versus time for the race. Use the graph to determine her average speed. Well, we'll need a definition for average speed. Average speed, is equal to total distance over total time. The symbols are a little bit more confusing because speed is actually V and it's S over T. So what is her total displacement? I read off on the graph and I see that it's about 100 meters. And I read off on the graph and I see that it took her 12 seconds. So I take 100 and I divide it by a time of 12 and I find that I get 8,3 meters per second, and the answer is therefore D. The average acceleration in meters per second squared of the object which the motion is represented by the following velocity time graph is. So we've got velocity and we've got time. What do we know about velocity time graphs? We know that for a velocity time graph, we are always going to get the gradient is equal to acceleration. So we want the acceleration, so we're going to work out the gradient. So it's y2 minus y1 divided by x2 minus x1. y2 is going to be, let's say, 15 minus minus 30, so it becomes plus 30. Remember, that's negative, negative. And then the points are 4, 5, minus 0. And when I plug that into my calculator, I land up with an answer of 10. And therefore, I get positive acceleration. Notice it is an uphill slope on this graph. And therefore, I am going to get a positive 10 meters per second squared. D is your answer. Tarishay is driving a race car along a straight horizontal road. The motion of the racing car is depicted in the following velocity time graph. What distance in meters was covered by the car in 40 seconds? Now, 40 seconds is the entire journey. Distance means that I am not going to subtract that triangle. I am going to add that triangle. Remember, if I have a velocity time graph, that by definition, my displacement or distance is going to be the area under the graph. So I need to start calculating some triangles and rectangles. And that is going to be equal to half of the base, 10, multiplied by the height, 8, plus this rectangle, which has a base of between 10 and 30 is 20, and its height is 8, plus I have half of, it's a triangle again, half of a base of just 5, multiplied by a height of 8, and now the big thing is to add that, plus half of, again, the base here is 5 of that triangle, 5 multiplied by negative 8, but I'm going to keep it positive because I'm looking for distance. When I add all of those values together, I find that I land up with 240 meters. So my correct answer is D. GQ is flying an aeroplane with a velocity of 180 kilometers per hour, lands on a runway that is 250 meters long. What is the minimum acceleration for that aeroplane to stop in time? The first thing that I'm going to have to do is change that 180 kilometers per hour into meters per second. So we're going to need to go 180,000 meters divided by 3,600 seconds. And that turns out to be 50 meters per second. Now I have got a initial velocity, that's my initial velocity. I've got a distance of 250 meters. I need to stop. So my final velocity is 0 meters per second. And I am looking for acceleration. So I'm going to use v squared is equal to u squared plus 2as, and substituting in the values, 0 is equal to 50 squared plus 2, I don't know the acceleration, and the distance is 250 meters. And when I rearrange that, not forgetting to square the 50 over there, I land up with an answer of 5 meters per second squared. So C is your correct answer. Two vectors have a magnitude of 9 kilometers and 6 kilometers. Which of the following is not a possible value of the resultant of those two vectors? Remember, if I'm going for maximum resultant, I add, so it's 9 plus 6, and I land up with 15 kilometers. If I take a look at the minimum of those two, I'm going to get 9 minus 6, which is going to be 3 kilometers. Now, since that is the maximum and that is the minimum, any number in between 15 and 3 is possible. So, 5 is possible, 15 is possible, 3 is possible. The only one that isn't in those boundaries is 2 kilometers, and therefore A is your correct answer.